So let's talk about the first form of energy that we're going to keep track of, and that's the kinetic energy. So the kinetic energy is energy that an object possesses due to its motion. So kinetic energy cares about how an object moves. You can define the kinetic energy in terms of the work required to accelerate an object from rest up to some speed v. So how do you calculate that? Well, you calculate the kinetic energy of an object. We're going to use big K for this. It's equal to 1/2 mv squared. So here m is the mass of the object and v is its final speed. So what is this equation telling us? Well, the first thing it's saying is that kinetic energy is a scalar quantity. So notice there are no vector symbols in that equation, right? So kinetic energy doesn't care about the direction the object is moving in. Instead, it simply cares about two things. It only cares about how massive your object is, that's the m, and how fast it's moving. So that's speed, that's the v. And again, it cares about those two things in slightly different ways. So if you double the mass of your object, but keep it moving at the same speed, twice the kinetic energy. If you keep the mass the same, but double the speed, notice that because that 2 becomes squared as well, you've actually got 4 times as much kinetic energy. So kinetic energy depends on both the mass of the object and the speed it's moving at, but it depends on them in different ways. Lastly, kinetic energy, like all forms of energy, has units of joules. So again, if we just think about our equation here, 1/2 is just a number, it has no units, mass has units of kilograms, v, that's a speed, that's meters per second, it gets squared, so I've got kilogram meters squared per second squared, and again, that's just what a joule is in base units. So just like any form of energy, work, any transfer of energy, all of those have the same unit of joules.